engines. Animagraphs already has an existing video about the inner workings of a jet engine. So for this video, we'll focus on the engine's relationship to airplane function overall. The rear of the engine case or cowling houses the thrust reverser assembly, which reverses fan thrust to slow the plane down just after touchdown, reducing wear to other landing parts and allowing shorter landing distances. The cowling exterior is a translating sleeve that moves backwards, pulling a ring of connected flaps into an angled position to block and reverse the normal path of thrust. Auxiliary Power Unit. The APU is a backup power source that can supply energy to things like cabin air conditioning, cockpit avionics, and so on when the plane is grounded and not yet connected to an airport power source. The APU also provides power to the main engines for starting. Pressurized air from the APU turns a small turbine device at the engine, which rotates the main gearbox and engine internals, starting the fuel and airflow process on which jet engines function. The APU itself is a gas generator that runs on principles similar to the core of a jet engine. The APU has an electric battery-powered starter. Air is drawn in through a port at the rear of the plane. It's mixed with fuel and ignited, and the resulting combustion drives a turbine to pressurize more air for various purposes, or run an electric generator. The APU exhausts out the back of the plane. Fuel. The center box and most of the internal wing area form a giant system of fuel tanks. The main containers are the left, center, and right fuel tanks. This plane can hold a maximum 5,681 gallons of fuel, weighing in at 38,350 pounds. The same ribs that provide wing structure become baffles with cutouts that let the fuel travel through the tank but also avoid excessive sloshing. Fuel enters through a port in one wing. A refuel-defuel panel in the wing-to-body fairing controls the fueling process and also shows fuel levels. Shutoff valves automatically open and close to ensure tanks are evenly filled. To greatly reduce fire risk, normal air in fuel tanks is replaced with nitrogen-rich air after refueling is complete. Bleed air valves on the main engines siphon off pressurized air, which is then cooled and passed through an air separation module to remove some of the oxygen, leaving a more nitrogen-rich product, which is then pumped into the fuel tanks. Surge tanks at the end of each wing act as vents for the main and center tanks, and have a NACA-style scoop that forces air into the tanks during flight, keeping positive pressure on the fuel system while allowing pressure changes depending on the elevation of the plane and the temperature of the fuel. These scoops also allow air to escape from the system during refueling. One-way flapper valves allow fuel to flow back into the main tanks, but not in reverse. The main fuel pump is located inside the jet engine casing, attached to a gearbox which is powered by the jet engine. Smaller collector tanks in each wing remain constantly full to provide uninterrupted fuel supply to the engine. To accomplish this, many supporting fuel pumps work to transfer fuel as necessary from the center and wing tanks. These pumps, called motive flow pumps, work by pressure alone, without moving mechanical parts, for simplicity and reliability. Fuel from the engine-mounted main pump flows through a nozzle into a narrowing tube, creating lower pressure in the chamber behind the nozzle, which sucks up fuel into the stream. Electrical boost pumps in each wing can act as a backup if other pumps fail. During normal operation, motive flow pumps transfer fuel from the center tank to main wing tanks, to collector tanks, and then to the engine. Air management. While in flight, pressurized air for crew and passenger spaces is collected from both the low and high pressure compressors inside the engine through bleed air valves.